Finally, we are about to start the Python class, the long-awaited Python class. So before we begin, I want to just take you through a brief history of Python so that we will understand why we are learning this language. We just concluded SQL series, and like I told you before, SQL is a query language that enables you to query, or that is, you write and read data from the database. Now, there is the how, the what question. The what question is what SQL language answers for you when you say, what do you want? But when you ask, how do you want this what to be presented to you? SQL cannot do that. So you need an object-oriented language. And Python is one of such language. So what we want to do now is how to integrate Python with SQL in order for us to pull out data from the database and then give a proper presentation to people to be able to use and come up with information that they can extract from the data. So right now, I'm going to give you a brief introduction into Python, and then you will understand why we want to learn this language. There is something I really want you to note while we go into learning this language. I want you to understand that we are living in a multiverse. So the world that you are looking at is like your computer screen or your phone screen. So you are being projected on it. Now, you are not living on the screen. You have a place where you are living. Your body is like your body is like a soccer jersey that you put on to go into the football field to play the match. But the field is actually the platform where the game takes place. So Python has a world, a universe of Python, where you are going to speak the language. There is the mathematical world, there is the English world, there is religion. So we will see some symbols in this world of Python that is similar to the world of English, that is similar to the world of mathematics, but they mean different things. So what I will advise is learn to understand when I'm moving in and out of this different world. When I'm in the mathematics world, when I'm in the Python world, when I'm in the English world, I will take my time to explain them to you. And I will be showing you how I'm doing this movement so that you'll be able to understand. But the key thing is you need to understand when we are dealing with data, and you need to understand when we are dealing with code. That I'll be explaining to you in this class. So, but before then, let's go into a brief introduction of what Python is and how we came about that name, Python. Okay, history of Python. History of Python programming language. Python, the programming language we are discussing today, has an interesting origin. It was created by Guido van Rossum, a talented Dutch programmer, back in the late 1980s. Guido was actively involved in the development of another programming language called ABC, while working at a renowned computer science research institute known as Centrum Wiskunde Informatica in the Netherlands. However, in 1991, he embarked on a new journey and introduced Python as a successor to the ABC language. Now, you might be wondering about the name Python. It is worth noting that for many people unfamiliar with programming, Python conjures up images of a certain species of snake. However, Guido van Rossum's choice of the name Python had a different inspiration. He drew it from a popular British comedy series called Monty Python's Flying Circus, which aired on the BBC. Even before I made this research, I actually thought too that Python was synonymous to the python snake. That was what I thought initially. But from what we've seen here, that was not where he got his inspiration from. Guido van Rossum played a pivotal role as the principal architect of Python, and his contributions were so significant that the developer community affectionately referred to him as the benevolent dictator for life. This title symbolized his leadership and influence over the language development. However, in 2018, Guido decided to step down from this role. Since then, the responsibility for overseeing the development and distribution of the reference implementation of Python has been entrusted to a non-profit organization called Python Software Foundation. This foundation continues to nurture and support the Python programming language, ensuring its growth and accessibility for developers worldwide. Guiding principles. Python was created with a set of guiding principles known as the Zen of Python. Some key principles include readability count. Simple is better than complex, and there should be one and preferably only one obvious way to do it. You'll be seeing many of the other principles. I will show you how to find it out from the database, from the Python language world itself. Python. The first version, Python 0.90, was released in February 1991. Python 2, released in 2000, became widely adopted, but it had some design flaws and inconsistencies. Python 3 was introduced in 2008 to address these issues. The transition from Python 2 to Python 3 took time, but Python 3 is now the standard and is actively maintained. I'll be downloading Python 3.x to use for this. For the lecture, I'll be downloading Python 3.x. Python's popularity has steadily grown over the years due to its simplicity, versatility, and a large and active community of developers. It gained widespread adoption in web development, scientific computing, data analysis, and machine learning. Python today. Python is one of the most popular programming languages in the world. It is used for a wide range of applications, including web development, data analysis and visualization, scientific computing, machine learning, and the more. Python has a strong relationship with SQL, structured query language, due to its versatility as a language for data analysis and manipulation. Python can be used to connect to databases. I actually demonstrated this in my closing class or the closing series of learning SQL. So you can look at that and see how I did the connection. But I'll be showing you that as we go on in this world of Python. You can execute SQL queries from Python to retrieve, insert, or update or delete data in databases. This integration is essential for data analysis and database-driven applications. Python's popularity in data science and availability of libraries like pandas and scikit-learn make it a common choice for working with data stored in relational databases. This seamless integration with SQL databases has contributed to Python's position as a dominant language in data analysis and data-driven applications. Analogy between SQL and Python. Okay, so I actually finished the SQL series. Now I want to go into Python. So to do that, let me just give you an analogy between SQL and Python. At the beginning of my SQL class, I showed a diagram like this, which is application, DBMS, and the database. I actually explained this structure. So I'm going to do analogy of Python with this diagram, looking at which part is the application, which part in Python is the DBMS, which part in Python is the database. Now, in this SQL, I told you that database is actually where the data are stored. Now, the DBMS contains the code that you are going to use to access the database in order to pull out the data. Then the application is the platform in which you are going to use to interface with the database through the DBMS. Now, I'm going to show you something similar to this in the Python world. So that is the analogy that I want to demonstrate. So looking at this analogy between SQL and Python, from the diagram I just showed you now, SQL database. Database stores data. I need you to understand. This point is very, very, very crucial for you to understand this Python class that we are going into. In SQL, database stores data. Now, what is similar to this SQL database in the Python world? So I told you we are actually living in a multiverse. We just concluded the SQL world and we dealt with SQL language. Now we are moving into the Python world. And in this Python world, we are going to speak Python language. But there are some similarities. So I'm going to do an analogy. Since we have actually looked at the SQL class, I'm going to give you some analogy in order for you to be able to understand this Python class. Now, in the database class, database stores data. In the Python world, what is similar to the database is what? Python libraries. So the Python libraries are collections of pre-written code and functionality that can be imported and used in Python script. These libraries provide specialized tools and capabilities for various tasks. Python libraries store code, functionality that can be accessed and utilized. So just like you have the SQL database that stores data, the Python libraries stores code. So in the Python world, we have code in one hand, and then we have data that we are going to deal with in the other hand. Where would this data come from? We are going to supply the data. Fine. But a time will come when we will have to integrate this Python world with the database world. So the database will keep the data, while the Python world will keep the code. And then when you mesh them together, the code will now work on the data and give you your output. So like the database world, where you have the database storing data, in the Python world, we have the library that keeps code, that stores code in quote. So I need you to understand this so that when we go into the Python world, you will actually understand what we are dealing with. We have the DBMS in the database. So I told you the database, the DBMS, and the application. Now, I have shown you what we store in the database, which is data. In the Python world, we have the libraries that stores code. Now, in the database, we have the DBMS. The DBMS provide tools and interfaces for managing and interacting with databases. In the Python world, we have the word Python IDE, Integrated Development Environment. I am going to use a particular type of IDE to operate with it, and that is PyCharm. Now, Python development environment, including code editors and integrated development environment, offer tools and interfaces for writing, testing, and managing Python code efficiently. So just like you have the DBMS in the case of the database that provide tools and interfaces for managing and interacting with the database, in the Python world, we have the Python IDE. Then we have, when we're doing the SQL class, we had the SQL developer, which we're using to interact with the SQL database. Now, SQL developer is an integrated development environment IDE designed specifically for working with SQL databases. It provides a graphical user interface and tools for managing databases and writing SQL queries. Now, in the Python world, Python has a programming language, serves as the environment in which you write and execute code. It provides the fundamental construct, syntax, and execution capabilities. So in the Python world, we have Python, which is what? A programming language that we are going to use. We have the IDE, which in this case now we are going to use an example of PyCharm. That is like the DBMS. And then we have the database. In the Python world, it is the Python libraries. So at the end of the day, when we mesh these two worlds together, we are dealing with data in one hand, code in the other hand. So you pull your data and then the code will work on this data. That is basically it. So that is what programming is all about. Now, my channel is religion, science, and technology. So I'm going to be moving into different world as I explain this Python class to you, because I have a goal, and I'll be explaining this goal to you as I go along. In religion, we talk about faith and work. You say faith without work is dead. So in one hand we have faith, and in the other hand we have work. So what is faith? Faith simply means data. What is work? Work means code. So pull the data, pull the code, match them together, and then you will get the output, which is what? The manifestation. I will be explaining this as we go along. So in Python, we are also going to supply data, and we are going to supply code. And then these code are going to work on this data to give you an output. Then when we merge the Python world with the SQL world, it means that this your data will be stored in the database, in which you are going to use SQL language to pull and then supply it to Python in the Python world. And then this Python language is now going to work on it and give you an expected output. So I need you to really understand this concept, so that as we go along, it will not be confusing to you. It's very simple, very straightforward. Understand two key things that I want you to take away from this particular video. What I want you to take away from this video is that there is data in one hand, there is code in the other hand. When you mesh them together, you are supplying the data to the code to manipulate and give you an output. So we'll be seeing this practically. It is important to note that analogies can vary based on individual interpretation and context, and different analogies can be used to convey the same fundamental concept effectively. The choice of perspective can depend on the context and the specific aspect of Python and SQL you want to emphasize. Like for me, I want to emphasize the part of data analysis. So I'm going to be dealing with data, and then how these data come out for you to be able to analyze. So that is the context in which I'm giving you this explanation. So I'm going to stop here. I'm going to stop here for today. In the next video, I'm going to explain the difference between interpreter and compiler. What is compiler and what is interpreter?